All right, let's wrap up chapter 7 and talk about elimination reactions. So, elimination reactions. So, when we have an elimination reaction, the first thing we need to remember that our product will be an alkene. So, if we have a product from elimination reaction, it's going to be an alkene. So that means some compound that contains a double bond. Okay. Now, so if our product is always going to contain a double bond from elimination reaction, in general, we start with an alkyl halide. Or an alcohol. And from there, we eliminate two specific atoms in a molecule and we get a alkene product. Okay, so let's look at an alkyl halide, for example. Let's say we have, use a very simplistic one, and Br. So, in an elimination reaction, we're going to have an alkyl halide, and we can say a base or nucleophile. We'll talk about the specifics of a base or a nucleophile later. But this reaction, if it's an elimination reaction, it's going to give us this product. Which is the same as this. Okay, so what we have to keep in mind is how did I get that specific product? And what we want to be able to do is we want to identify alpha carbons beta carbons, and from your beta carbons you can get beta hydrogen. So actually in your older textbooks the elimination reaction is called a beta hydrogen elimination. Okay, so first rule is that the alpha carbon is the carbon attached to the alkyl group. So in this case, this carbon here is attached to the alkyl group, so that's your alpha carbon. Okay? Now, your beta carbon is adjacent to the alpha carbon. So carbons that are direct neighbors to the alpha carbon, they are considered beta carbon. So this is a beta carbon and this is a beta carbon. Okay. Now, what we're concerned about is the number of beta hydrogen, because an elimination reaction takes place between elimination reaction takes place between the alpha and beta carbon. So what we're actually eliminating is the halogen. If I come back up here in green, we're eliminating the halogen, or you could have an alcohol that's being eliminated, and we're eliminating a beta hydrogen. So the hydrogens that are attached to the beta carbons are beta hydrogens. So beta hydrogens are attached to beta carbons. So the product, I don't think we'll go through the mechanism, but the product is quite simple. So if I draw that example again, and this is actually what, 1, 2, 3, 4, 5, that's 3 bromopentane, and we have some nucleophile or base. What we want to do is we want to come in, okay, what's attached to the halogen, what carbon, we want to label that alpha, and then we want to come over and we want to label the beta carbons. So each one of these hydrogens are beta hydrogens that are attached to the beta carbons. So we want to eliminate, so we lose the Br and we lose one of the hydrogen, and we draw a double bond in between the alpha and beta carbon. So we would have this like that, or if we chose this hydrogen here, we would have that. So we're actually eliminating one of the hydrogens and the halogens. So this is where your HBr portion would come from, right here. So this is our major product. All right. Let's look at another example. And we just want to get familiar with labeling the alpha and beta hydrogens. Let's see if I have. Let's say if we have this alcohol, okay? So the same rule is going to apply. The carbon that's attached to the alcohol is going to be as if it's the halogen. So this is the alpha carbon, okay? So your adjacent neighboring carbons that's attached to alpha is going to be beta. And you can go out and draw out these hydrogens. Okay, so one thing that can happen is I think we'll stick with halogens and alcohol. We can eliminate an alcohol and turn that into an alkene. So in red, we're going to lose the alcohol and we're going to lose one of the beta hydrogen. So if we had a base or a nucleophile, this would be your product. We would have this, and you still have your two hydrogens right there. One hydrogen here. Or I could eliminate the other side, which is actually the same thing. I could have a double bond here. One hydrogen left and two hydrogens here. So we really want just a simplistic way to be able to understand the product of elimination reactions. What type of product are we going to get? Okay. All right, let's try another example. Let's say that we have a structure such as this. Okay, and we're going to put that, and we're going to have a BR there. All right, and I'm going to put this nucleophile CH3O minus. Going to let that act as a base. Now, the first thing we want to do is look at the carbon that's attached to the halogen, and we want to name it alpha. Okay, and what's going to be beta is every adjacent carbon that is attached to the alpha carbon. So this is going to be a beta carbon. This is going to be a beta carbon, and yes, this here is going to be a beta carbon. So we have 3 beta carbons, and guess what we got? 1, 2, 3, 4, 5, 6. We have 6 beta hydrogen. Okay? It's very important for you to understand how to identify what is an alpha carbon and what is a beta carbon. Okay? So, let me draw this out again. And let's see. Okay. And if we have CH3O minus. So we want to drop the halogen, and we want to draw a double bond between every possible alpha carbon and beta carbon. So there's only going to be one alpha carbon, so we have a beta carbon right here, so we want to draw a double bond in between that. Okay. Another product we can have. Drop the Br, we can have a double bond between that alpha carbon and this beta, or we could have one more. So if we keep in mind that this is alpha and this is beta, so we would have a double bond in between that alpha and beta carbon. So these are all possible products, all possible products of elimination reaction. Okay. Now, of course, there are rules that govern exactly what type of product that we're going to get. Which one of these are preferred, 1, 2, or 3. That we will talk about, but for the most part, we definitely need to be able to recognize what products that can be generated from an elimination reaction. So in order to do that, we must be able to recognize the alpha carbon, the beta carbon, be able to lose the halogen and a beta hydrogen and draw a double bond in between the alpha and beta carbon. Okay, let's see. If we tried perform X. Alright, let's try a few examples. Predict all possible products. Alright, so let's start with this. Let's start with that double ring and BR. And for right now, I'm just going to say elimination. Okay, that would be 1. Let's see if we can do this ring. OH. Elimination. Let's see, number 3. Can we BR and say elimination. Try another one, the 4th one. All right, let's try those 4. And in our next discussion, we'll talk about what products are more favored than the other. And we'll get deeper into an elimination 1 reaction, which is E1, elimination two reaction E2 and competition between substitution and elimination.